My name is Alexis. I work at Google, and today I'll be talking about two things. One is where serverless, I believe, is going, and not just from the Google perspective, but hopefully when it comes to cloud, but also on-premises. So what you can expect for the coming months and years when it comes to serverless in those two contexts, both cloud and in your own data centers. That's the first thing. The second thing is trying to share some of the lessons learned by Google running services internally at a great scale. And hopefully these are some of the best practices that you can apply to running your own services through some tools and through some methodology. So let's start. Obviously, I was enough to use serverless in the title of my talk, so now I need to define it. So this is how we look at it. Serverless is there are really two axes. I only have one here, but there's the operational model. Obviously, that's the typical thing. Yes, there are servers, but you don't get to manage them. We'll get back to that. The second thing is everything auto-scales. No traffic, no servers, no cost. Speaking of cost, if there's traffic, well, there's cost associated with that. That's the typical model, at least in the cloud, that you would have. Of course, if you're on premises, you've bought the machines and, they cost something up front. But if you're in the cloud, you pay for what you use. Again, no traffic, no cost. And there's some free tiers and free trials and free everything. So, it's fairly cheap. So that's one side. The second aspect, which is more for developers, which is more about the paradigm with which you program, one is that it's services-based. Services means two things, really. Both the fact that you consume services, rather than talking to a database on a specific host on a given port, you will request a service and you will manipulate that service. And you don't really know where it's located. You don't really know if it's one server, if it's multiple servers. Maybe you don't even know where it lives in terms of regions. Maybe it's distributed, and we give you 5 nines, 6 nines, and we guarantee data integrity. The second part of service-based is that you yourself are also exposing services. You're part of this bigger world where maybe you call them microservices, maybe there are dependencies between them, but you're in this world where you don't reinvent the wheel, and hopefully what you bring adds value and other people can reuse your stuff as well. And finally, and that's really important, there's the event-driven aspect. Events can be many different things. It could be somebody logging into your system. It could be a file being uploaded to a directory or to a bucket in a storage service. It could be a message posted to a service bus. It could be a machine starting, failing, whatever it is. It could be many different things. And instead of reacting to a user request only, your services can be triggered by one of these events. So this is what we mean by programming paradigm in the context of serverless. So let's play, and of course, serverless also, some people apply this to many different things. I will focus on the compute aspect of things. But you could argue that something like a database could be serverless, because you don't get to manage the servers, or provision the size, or do capacity planning. You just deploy your data, and you don't even have to manage indexes. Maybe that's the case, in which case that would be a serverless instance. But let's focus on compute. So time for a quick survey. So who thinks here that serverless is about deploying functions? Obviously, right? If it's serverless, it's got to be a function. Anybody? Second is, well, it's applications, really, because functions, what can you really do with functions? It's just glue code. At some point, you're building something bigger, so it's got to be functions. Anybody agree with that? Okay. But wait, no, it's containers. Everybody's using containers nowadays. And it's so easy, so convenient for developers. You get to say what image you're based on, all your dependencies are there, you package this, and whatever you had on your laptop runs in production. Who thinks that's a good approach? They're all good. Why would I decide for you that one of these is the right one? So I think this is where we're going. And let me try to explain why that is. Just as an example, and my goal is not here to give you detailed information about products, but at Google, for Google Cloud Platform, we have two products. We have Cloud Functions and App Engine. functions, apps. And really, the goal in this case is building applications and running those applications without ever provisioning a server. Don't manage it, don't stop it, and don't maintain it. It's neither physical nor a virtual machine. So let's see why two products. Well, functions are really something, as I said, that react to events. And events can be many different things. And an HTTP request coming in is just a special case of one of those events. And that's a very valid one, just one of many. Typically, the function will get that request, get that payload, get something with the data, and in turn invoke other services. And if you live in a cloud, there are many services you can talk to, like persistence services, maybe some machine learning services, maybe, whatever it is that you want to use. So hopefully you have the choice of a programming language, so you don't have to relearn a language. So hopefully maybe it's Java, maybe it's Python, maybe it's JavaScript, whatever it is. And hopefully, whatever you end up using has all the right libraries that you need. Language is just one thing, but there's, as you well know, in Java, it's an ecosystem, and there are many things that come with it. And the developer experience is very important. If I tell you need to use something new that competes, that's different from Maven and Gradle and maybe something else, it's not really Java because you're used to using either one of them. If you need to package all your files differently, that's not a really good experience. So hopefully we address that. Hopefully you also have a long list of events, many things that can trigger your functions, not just HTTP or uploading files to buckets. There are many more. And then you have a lot of things you can invoke in the backend. So a machine learning API, recognizing what's in an image, for example, translation, storage, many different things. And of course, you want all of this to be monitored and managed. And we'll get to that in the second part. So that's functions. Typically, a function is deployed, in the case of Google, with a deploy command pointing to that function, the source code. Well, to be honest, and the source code could be in different languages. To be honest, it's a bit more tricky than that. You need to say how that function is triggered. What is the event? It's a file being uploaded to a bucket. It's an HTTP message coming in, so forth. Maybe you want to set parameters. Maybe you want to set explicit environment variables. There are a number of things that you can add, but essentially, that's all you do. Like, there's no create cluster. There's no manage cluster, resize cluster, none of that. We do it for you. Let's talk about applications. Well, applications can be a bit more complex, obviously, than functions. That's the whole reason they exist. Typically, they're broken into services. You want to call them microservices if you want. I don't want to talk about what's a microservice, what's not. But typically, what I do want to say here is that every service probably has different versions, because you're testing things, because you're building new things. And those versions can actually maybe even all be active at the same time. And you might be splitting traffic, routing traffic based on rules to different versions of the same service to see how they behave and how they're different. So what you deploy is an application that has multiple services, so the dependencies are explicit in this case. Hopefully you still have the choice of a language, of your favorite language. This is probably ends up being exposed as a front end. The versioning I just mentioned, the traffic splitting is one thing you can do because you have that versioning. And of course, you still want end-to-end monitoring. You want to see what's going on, how much traffic are you getting, where are you getting your errors, and that kind of thing. And the scaling might be different. Why would you have different versions or different services? Because the front end might need to scale horizontally very fast. Maybe the admin service, which is used by just a few people, does not need to scale as much. So the instances part here is really about physically how this is being materialized into probably multiple servers. So you can have rules that say, I want to be super aggressive in spinning up new instances because I want to respond to demand, and I don't care how much it costs, or I want to be just, make sure I spin up a new instance because it's going to cost me a little bit more money, only when I really need to do that. But you don't get to control exactly when that is done. The deployment in this case is well, a deploy command, and in this case, there are no hidden options. You point to a local directory that has your code and maybe some metadata. In the case of Java, it's a deployment descriptor that has a few additional parameters about where the different services are and what their names are. But essentially, you could package this as a WAR file and deploy it. Now, oops, I said everything, right? Functions, apps. What about containers? So who uses Docker here? Of course, quite a few. So Docker has been an amazing technology to popularize containers as a technology. And a lot of people use that because as developers, it's really easy. You get to pick everything. Maybe you get to pick too many things, but we'll get back to that. But if you're into developing with containers, you probably are using something like Kubernetes, where you have multiple containers and they need to be spin up and they need to be up and running, and we have the notion of pods and you replicate them, and Kubernetes does all of that for you. Now, what would be nice here is if we had an image and you didn't have to explicitly use Kubernetes. Because when you use Kubernetes, you have to create a cluster. And only when you have a cluster, you can deploy something to it. And then you need to expose that service. So there are a few additional steps. Well, what we currently have is something called deploy. And the only option you give it is a URL of a container living in a registry somewhere. No, I do not want to leave this site. I apologize. And that is something that we call containers for Cloud Functions. So use the environment that we have for Cloud Functions, use that infrastructure, and run containers completely serverlessly. No cluster, none of that. We do all the scaling from 0. Remember, it's not serverless if it doesn't scale to 0, to whatever the capacity to serve your load. If you're interested in that, we have an early access program, and this is the address you can get it to, g.co/serverless containers. Now, this is nice, but this is you giving your container to Google and putting it in the cloud. And that may or may not be possible in some cases. Maybe you want to run this on a Kubernetes infrastructure because you've invested in Kubernetes already. You just don't want to deal with it. So that's what we have to offer with something called Serverless add-on for Kubernetes. Say you've invested people who are using Kubernetes today, you can add an add-on on top of it and make it look like a serverless platform. That is something that's built with Knative. Knative is making Kubernetes look like a serverless platform. It's adding things on top of it. It uses Istio. It uses a few other technologies to make it look like a serverless environment. And this is a very good approach if you have invested in Kubernetes already but want to provide your developers with a serverless experience. And that is also something we have as an early access program. And the reason I mention these two is because I think these are trends in the industry. Of course, we're leading this. We've, at Google invented Kubernetes. We've done cloud for a long time. And so we're doing these things. But I think these are things you'll see as equivalents in different cloud providers, as well as on premises. Because if you can run something like the serverless add-on on Kubernetes, of course, that could run on GKE, which is Google's Kubernetes, but it could run on premises on your own Kubernetes as well. So the reason you want to do this is mostly because you don't want to be locked into Google or anybody else. And we don't want you to be locked into Google because we know that's a problem. The workloads really, really need to be portable, and the right-hand side here addresses that. All right, let's go back to serverless as a name. Everybody who's in serverless has a love-hate relationship with serverless. Who thinks serverless is a good name? Okay, there are a few. I'm not sure. First of all, it defines something by what it's not. So maybe that's not a good start to define something. I actually have some colleagues who are in a totally different environment at Google who thought really there were no servers. Like it was just, not clouds, but small machines collaborating and coming together to bring services. Now, of course, there's servers. So let's see. How about we call this no ops? I mean, you don't get to do, spin up machines and clusters and all that, so you don't do operations. Who thinks that's a good name? Oh, maybe even actually a few more. Okay. No, that's actually not a really good alternative. And the reason for that is that you're delivering a service. You just happen to write it in a serverless fashion, but you're still delivering a service. So if you're doing that, you better be managing that service. You're providing availability for that service, performance, all of that needs to be managed one way or another. But there are challenges with serverless. They're specific to serverless. First of all, you don't get to install an agent for your favorite logging monitoring framework. That doesn't work that way, at least at Google. We don't get you to SSH into the machines. Can't do it. The second thing is, remember that auto-scaling is because you have many different workloads, and the utilization of all the machines is very, very high. Much higher than if you had a dedicated server. Dedicated servers run at 10% peak, and they're sized for peaks. If you can have multiple workloads on the same machine, you have really good economics. You can pass this on to customers. So that's what we do. But the flip side of that is that things keep going up and down all the time. You don't have like a server always there which you can monitor. You have multiple instances. They can come up, go away because there's no traffic, come back up. There can be many different ones. So when it comes to managing all of this, it's a bit more complicated. The other thing is that, remember the services approach? Well, there's you as a service. Maybe there's multiple services. There's the one you call. There are a lot of dependencies. There can be cascading failures. So that also was maybe easier if you had one big monolith. Something comes in, something goes back out, and that's easy to monitor. Whereas here, it might be distributed. You don't have control over everything. So that adds a little bit of complexity. And finally, the event aspect. It's not like an HTTP request coming in or a TCP request coming in and something going back out. It's more complex than that. There might be one event triggering multiple actions. There might be fan out, fan in. There can be queues. There can be asynchronous work. So all of that makes it a little bit harder to monitor and to troubleshoot. So let me get you to work a little bit. Let me show you a demo. So there's a QR code, there's a URL over there. So if you have a phone and you have a connectivity, you're welcome to use that. This is a mobile application. It's a website. It's a PWA, Progressive Web App, if I want to use the exact term. And it's a photo sharing application. So what happens is you typically click on the icon, you get to take a picture, and it's uploaded to Google Cloud. We run this through what we call the Vision API, and it will return with a number of tags of things that it has found in the photo. Now, it will also calculate the most popular tags. And because I don't trust everyone, I trust you, of course, but I don't trust everybody. This is on the internet. Anybody can use it. I have an admin aspect to this app, which lets me moderate and filter out anything that shouldn't be published publicly. The Vision API actually has this safe search feature. So if an image is not safe to show, it can be flagged. And then when it's flagged, I, as an admin, get to delete or publish if it was a false positive. So the way this works is I upload a photo. My front end will actually get this. It will store the picture in a bucket. It will also read some data from a database to show the most popular tags. The fact that we had something posted to the bucket will trigger a function. That's one event. That function will call the Vision API, get some results back, and write those results to the database so we can calculate that list of most common tags. And finally, there's another function that on a regular basis will calculate those most popular tags. This is quite an extensive and expensive calculations, so we don't want to be doing this on every upload, so we do it every 5 minutes using a cloud scheduler, which triggers every 5 minutes through a message posted to PubSub, another function. And finally, I have my admin app where I can go and remove some content that was not meant to be there. Okay, so we'll come back to this in the demo. But in the meantime, if you can play with it, I can see people already playing with it. Thank you very much. That will have me show you a few interesting things. Now let's switch gears and talk about how Google manages services and how maybe that can apply to things that you do as well. And this works well with serverless, but I think these principles work well in general when you manage services. This has to do with something we call SRE. Anybody has heard SRE before? So this is service or site reliability engineering. So let me break this down. Site or service, let's say service for now, that's obvious, that's the thing you have running. The reliability is a really key part here. But we'll see that reliability, you can achieve that in one way, but that will take away other capabilities for the team developing. So while it's key, it's not the only thing we have to consider. And engineers, because these people are software developers. This is a category of people that we have at Google that are super well respected, just as much as software engineers. There's software engineers that happen to also know things about maintaining services, running, and looking at their reliability. So if we were to compare this with DevOps, this is what we would say. The class SRE implements DevOps. Maybe you've heard of DevOps, maybe you have your definition of DevOps. At Google, our implementation of DevOps is called SRE. You think DevOps, we think SRE. It's really just our implementation. There are other valid implementations, but we believe that one actually works for us and might work for you as well. So at Google, we have a bunch of products that have more than 1 billion, that's a B, users. And we only have 2,500 SREs for all of these. If you do the math, that's for each SRE, that's 400,000 users. So that's pretty good. There aren't that many SREs. At Google, there are way more software developers than SREs. So how do we actually do this? They play a really important role. Like without SREs, these services wouldn't work the same way as they do today. The goal of an SRE is really to balance reliability, that's in their name, that's the R in reliability in SRE, with agility. You can make something very reliable by never touching it. But that's not what we do at Google. We try to iterate. We ship often, we ship fast, and we iterate a lot. And that's what gives us agility. That's what gives us, competitive edge. We don't want to be stuck and have releases only every year or so, because the cloud allows for continuous delivery. So we take advantage of that, and we do that a lot. And we have SREs that help us balance reliability and agility by trying to automate everything they can. So an SRE is not somebody who will be working up all the time, who will be running around because there's a disk failure or some file system is full or something. That's not what SREs do. Hopefully all of these common problems have been automated. Typically we have auto-scaling. If something fails somewhere, another instance will take over. Hopefully the software is built in such a way that a lot of automation is already in place, and we don't have to wake up the SRE every time there's a little something that goes wrong. I'll tell you when we do wake up the SRE in a moment. So I think there are a different number of things to build an SRE team and to have that in place. First of all, there's a culture. So we've tried to convey a number of things from that culture in a book that was published and that's available for free online. It's called SRE, Site Reliability Engineering, but services, site is kind of the same. And this is really important. Part of the culture, there the fact that an SRE can say, no, I do not want to carry the pager. Your system is not well automated enough. It doesn't have all the information that I need to make sure I can keep it running. You have not built it the right way. And that's a very powerful thing that SREs can do internally, which means that the teams that develop internally actually have to put a lot of things in place before an SRE is actually willing to carry the pager for a given service. The other part of culture is something we call blameless postmortems. Some things can go wrong and will go wrong. It's important to understand what led to this and to document this and document this in a blameless way. Don't say it was this person's fault. Maybe it is, but that's not the point. What do we do to make sure it doesn't happen again? That's really what we want to do. And let's be transparent across the team, or maybe even with our customers, what went wrong and what measures we've put in place to make sure it doesn't happen again. So postmortems is a big part of culture as well. So of course then there's tools, or tools, not actually tools, but infrastructure work. If you have, I think the ratio is 1 SRE for 20 engineers, the SRE is not going to go to 20 engineers and say, you need to log that data, you need to expose that thing, they have some very opinionated way about how you should log data and how you should operate. Every service has a name, every service is discoverable, every service is manageable. And we do this through a number of technologies, and we've open sourced some of them, gRPC, Open Census, there are a few others. The platform is really kind of a big time series database. This is where all of this data eventually ends up. And this data, and that's really only the tip of the iceberg, is presented through different tools that show different kind of monitoring, reliability, and other information. But that's really the tip of the iceberg. If you don't have the culture, if you don't have the infrastructure, if you don't have the time series database platform, the tools, the tools are not magic. Never have been, never will be. So this brings me to a little bit of vocabulary, which is really key, I think, to SREs. Who knows what an SLA is? Service Level Agreement. Most people talk about SLAs because typically we will tell you that even as Google, we will give you a 5-9 SLA, which means that we only have so many seconds of downtime a year when we deliver a database service, for example. But before we get to that, there are two other concepts. The first one is SLI, Service Level Indicator. A service level indicator is something that matters to the business. Having a disk that's full, having 80% of CPU usage, the customer doesn't care. The customer cares typically about two simple things. One is the service available? Two, do I have any errors? And what is the latency? Latency and errors, availability and latency. These are the two important things. Now you can define other SLIs, maybe for your business. How many things have I been selling in a given time? There are different things like business metrics can totally be here. Now, once you have those metrics in place, indicators, you want to make a promise to yourself, and that's called an SLO, an objective, a service level objective. That's the goal I have internally. So I want, for example, the 95th percentile of my request to be less than 2 seconds. And I want this to be true in a window of 1 hour. Now, the nice thing here is that, and the secret, is that Google never has a goal of 100. None of our services have a goal of 100% uptime. Might be weird, but if you do that, you cannot be agile. You cannot develop new things. You cannot develop new features. You cannot develop that. Like, we're really close to 100. We try to be close to 100, but it's never 100. And the difference between 100 and the SLO is the error budget you have. And once you start thinking about this as being a budget is something you need to use. You need to burn the budget. You can and you should use it, because otherwise you're not going to be given that budget again for the next cycle. So that's really how we think about it. And remember I said, I'll tell you when to wake up the SRE. When the error budget goes down really quickly, that's when you wake up the SRE, because the business is on the line, and that's really, really important. And the SLA is kind of grayed out here because it's not really a concept for SREs. That's the, kind of an SLO, which is less aggressive, which you make as part of a business agreement with something. But from technical perspective, SLIs and SLOs are really important. I mentioned versioning. I'll show you quickly in the demo in a second how we use that. It's really important to have multiple versions, that they all be active at the same time. You can do things like canary deployment, A/B testing. So you can deploy a new version and get only 1% of the traffic to go there, look at the logs, maybe increase to 5%, 50, and eventually move all the traffic there. You can do A/B testing. Maybe you have two versions. You want to send 50% of the traffic to one version, 50% of the traffic to another. I don't know, people get like 10% discount or free shipping, and you see which one works best. That's possible if you have multiple versions and they're all active at the same time. So let's go back to the demo and see what happened there. So let me refresh and see a few pictures. Okay, really interesting pictures. I get all those carpets all the time, so that's normal. So typically every picture has a few tags. Yes, this is furniture, this is a chair, and this is all automated, of course. Nobody is doing this. Somebody thinks there's a sky here. No, but it is kind of a seminar. Yeah, convention, technology, conference hall. And at that point, you can also click on tags and see all the tags that have been computed. And maybe let me make this a bit bigger and click one of them. Oops, I think I have an error. Turns out I was playing with this just before I started speaking, and I must have made a mistake. So let's see if I can try to find what the mistake is. Turns out I have a notification here on my phone. I probably have the same here in my email. Oops, we'll get to this. Yeah, I do. Okay, so the thing says here, Java lang exception. I'm a fake exception. Okay, it's interesting. Let's see what this really is. So this will send me to something called the error reporting. And it will tell me when the error happened for the first time, how often it happened, and of course what the error actually is. If I look at this, I think I remember what this is. That's me just being facetious and adding some artificial problems. But let's see if we can look at something else here. If I look at, and this is my admin, so if there's some things that were flagged as being something that I shouldn't show, like interestingly, this is something I tried. This is supposed to be violent. This is just my dessert. But, I'd rather have this. It's a false positive, so I'll let it go. But there may be other things that I don't want to let go. So let me look at something here called traces. Traces are interesting because they show you requests and all the subsequent requests that have been made. Typically, a request comes in, and then there's a call to the Vision API, and I'm writing to a database, I'm doing a number of things. And I can see here that there are a number of here that are above around 3 seconds, which is weird because if I was to go back for a 12-hour window, there are none of these. There's some here and then some recently. I've been doing something around that time. So maybe something's wrong and maybe I can zoom in and I can see what's going on. So this tooling are available really because I have a lot of things in place, because I have that really opinionated way of logging data and having that time series database. And turns out, actually let's go back to remember the error. I can look at the code. And really what I want to do, because I don't have time to code, commit, and do all of these things, I want to go to the versions. Remember I said multiple versions can be active at the same time? That doesn't mean that they get traffic. Currently, I have 4 versions here. This one is getting 100% of the traffic. I could decide to split traffic between 2 versions. It could be 50-50, it could be anything you want. It could be based on cookie, completely at random, or based on IP addresses, so you get some sort of sticky load balancing. Or, in this case, because I know what I'm doing, this is bogus, this is the version, this tells me that I have a problem. Well, this version, let's make sure I don't use it anymore and migrate live all the traffic to this new one. So yes, I want to go to current. I know current is fairly stable. I haven't had too many errors on this one. So hopefully at that point, after we've migrated all the traffic, and you can keep using it, and I actually have a bot that's using it, so that bot will be migrated. And eventually, we've migrated, and if we go back to tags, and click on one of these, typically it works now. Which means that, I'm back on a stable version. And it really was just a matter of pointing back to something. And now I can go and fix my error, and maybe look at the problem that I had, which was these are taking way too much time. But remember what I said about SLIs, SLOs? I'm too deep down into tooling here. What you really want, I think, is something like this. Is the ability to monitor an SLO. So I have an SLI here, which is a goal, which is to have the 95th percentile of my request to be under 2 seconds. Remember, this one was 3 seconds, so clearly I'm not meeting my objectives. So this is actually shown here in this graph. This is the indicators. This is the SLO. This is where it should be, that line, 95th percentile here. And I'm about here. So clearly, the error budget has been eaten completely. Like, I have no budget left. So what do you do when you don't have budget left? You go and you work on your reliability. So you go back to that version, which you know is stable. You go back to deploying new and developing new services and making sure, actually I was showing you old data. Let's see if that is a better graph. Yeah, it's even worse. I have even less budget left. None, actually. So when this graph goes down, this is when you wake up the SRE. At least that's how we operate. All right, in the 5 minutes that I have left, let me walk you through a few small things here. I'll skip through these slides. I'm sure the slides will be available, but these are essentially screenshots and tools that I've been using. So the recap is this. NoOps is not a really better term than serverless. I don't have a good term for you, but at least you know what we're talking about. Serverless can be a bit challenging when we talk about operations, and DevOps in particular, because of the things that I mentioned. At Google, we use SREs. That's our implementation. It works fairly well for us. It's starting to be really well adopted by the industry. A number of companies are hiring SREs. I mean, there are job postings for SRE. Now you know where this came from and what that means. And the tools are nice. I mean, the graphs are nice. But if you don't have everything in place, starting with the culture, it's not going to get you anywhere. And remember, you can deploy anything, functions, apps, or containers. And if you cannot do it today, I'm pretty sure you'll be able to do it tomorrow. And I'll leave you with just a few resources. There are actually 2 books. Both are free, and they're online. So look for SRE. And that's the URL if you want to look at it. And there's even a YouTube series if you're interested. So with a number of videos, really short 5-minute videos that tell you everything about SLI, SLO, SLAs. Everything about postmortem, blameless postmortem. When do you call somebody? When do you do these things? How do you manage incidents? That's the other part of the culture. So with that, do I have time to look at the questions real quick, or? Okay, 5 minutes. That's plenty of time to look at questions. Okay, so okay, cool. So, do you think that serverless will replace traditional backend development anytime soon? That's a good question. I think that is definitely the trend. I think as developers, we want to build new features. It might be fun to also do management, especially if you kind of like me, you like, middleware, you like operations as well. But most developers really are paid to write apps that do something. The infrastructure part is not the developer's role. So I think the trend is going that way. But until we have an ability to have a continuum where I can start with a function, because it gets bigger and more complex, make it an application, and maybe use containers along the way, and don't have to go into one of 3 directions. Until you have that, I think serverless will kind of plateau. I think it will be growing, but it will not replace traditional backend development just yet, because you can't just decide which technology to use. And then click again, and okay, -1. Should I still answer?
It's up to you.
Okay. In terms of security issue, what kind of solution would you utilize to protect serverless functions? So that's a good question also. -3, but still a good question, sorry. I get to overrule that. -1, okay, this is life. So if it's an HTTP function, I'm assuming that that is the case. And here, I don't have HTTP functions. Both the functions that I was using are triggered by an upload to a bucket or a message to PubSub. But if it is an HTTP, there are many ways to secure that. In the case of cloud functions, by default, they're not secured because we want to make sure the developer experience is easy. But then you can add gateway functionalities. You can protect this through anything that protects a HTTP endpoint. So yeah, I think you have a number of options. 3, it's green. Okay, now I understand the color coding. -4, wow. Yeah, the proper way to monitor is hopefully you have a number of things in place. So if you can trust your cloud provider to offer you tools as the ones that I showed, you're in a really good place. If you're running your own platform, or if you don't have that level, you might have to use and expose things yourselves and do some of the infrastructure work. Has to be Turkey-specific pricing strategy for cloud platforms. Just saying, come talk to me, we can talk pricing. -1.
Okay, I think crowd has had their ways with the questions.
Okay.
I
don't know if it's working.
Yeah, it's working.
Okay, it's working, perfect. Okay, I'll be around. If you have more questions, please come to me. Thank you very much for your attention, and have a great talk.
Thank you, Alexis.